Here's the second video on our part about trig equations. These are quadratic trig equations. I'd like to show you several examples on how to deal with those. Our first example is a simple quadratic equation that will factor using the greatest common factor. Sine square x plus sine x is equal to 0. You see these are still simple functions in that they only have one function, that is the sine, and these have a GCF, a greatest common factor. So we're going to pull that factor of sine out, and it will factor sine x plus 1. Just to remind you, you can never factor anything that's not set equal to 0. Once you get it factored, you take each factor, sine x is equal to 0, and sine of x plus 1 is equal to 0, and you solve each one. Sine x is equal to 0 is already solved, and now sine x is equal to -1. Now, this first question reminds us that sine is 0 where y is 0, which is going to happen here at the point 1, 0, and here at the quadrantal point -1, 0. So this particular value has two angles that satisfy it, 0 and pi. Sine x is equal to -1 where y is -1, which is here at the point 270, or in radians at 3 pi over 2. And so that one only has one answer. There are three answers in total for the problem. This is a greatest common factor quadratic that does factor and solve. My second example involves a quadratic equation that will factor in the normal way that you normally think about. This is example number 2, and this is tangent square x plus tan x minus 2 is equal to 0. All right, this one will factor in the way that you would normally think about factoring. That is a quadratic that will factor using the FOIL method. Factor the first term, tan x, factor the last term, 2 and 1, because it's prime, and arrange the signs so that you get the middle term. I need a plus 2 minus 1. So this is simple trinomial factoring using the FOIL method. Now, I want to pick up from here because this involves a little extra trig here. Tan of x is equal to -2, and tan of x is equal to 1. That's by setting each bracket equal to 0. Now this one is fairly straightforward. The reference angle here is pi over 4. That comes off of our 9-part chart. And tangent is positive in quadrants 1 and 3. So this answer is pi over 4 in the first, 5 pi over 4 in the third. So that's pretty straightforward. Now this one, not so easy. This is not on any chart. So for this, you got to get your calculator out. You ask your calculator, hey calculator, what angle has an inverse tan of 2? Remember, do not put this negative sign into your calculator. That is going to be used to tell you the quadrant. So we have a calculator that we ask about the tangent, and it says, okay, the reference angle is 1.11 radians. So here's my little cloud where I'm doing my thinking. I need 1.11 for my reference, and I need it where tangent is negative in quadrants 2 and 4. So 1.11 radians in quadrant 2 and quadrant 4. Here's a picture of that. Quadrant 2, we're going to go up from 3.14, and we're going to subtract 1.11, and we're going to end up at 2.03. So our first answer here is 2.03 radians. What is that? 2.03 radians. In fourth quadrant, I'm going to come this way from 6.28 minus 1.11. And that answer is going to be 5.17 radians. So this is 2.03 and 5.17. And then these two answers, pi over 4 and 5 pi over 4. All right, that's my second example that would factor. Now you can't talk about quadratics without talking about examples that will not factor. So here's our third example for this video. Cotangent squared x plus 3 cotangent x minus 1 is equal to 0. You don't have to look at that long to know that that will not factor. That has a, the factors of 1 will not give you 3 no matter how you look at it. So we're going to resort to the quadratic formula. Now the only difference here is that when you set up the quadratic formula for something like this, instead of saying x is equal to negative b, etc., you're going to say cotangent x is equal to. Now let's get our terms. A is 1, b is 3, c is negative 1. So cotangent x is equal to negative 3 plus or minus the square root of b squared, 9, minus 4ac, all over 2a. And this would be negative 3 plus minus the square root of 13 over 2. Go ahead and ask your calculator about the square root of 13. It's going to be about 3.6. So at this point, your cotangent is equal to negative 3 plus or minus about 3.6 over 2. Now that's going to split into two answers. Negative 3 plus 3.6 is 0.6 over 2, which is 0.3 positive. And negative 3 minus 3.6 is negative 6.6 over 2, which is negative 3.3. Now keep in mind we're dealing with cotangent here. So let's just go through the two options. Cotangent x equals 0.3. Ask your calculator. Here's what it's going to tell you. The reference is 1.28. Cotangent is positive in quadrants 1 and 3. And so that is going to be 1.28 in the first and 4.42 radians in the third. That's 3.14 plus 1.28. Again, you can pause that video anytime and check out why that is the case. Then for our second one, cotangent x is equal to negative 3.3. Remember, put in the positive. Here's what your calculator is going to tell you. It's going to say the reference is 0.29. We need it in quadrants 2 and 4. Solutions, 3.4 minus 3.14 minus 0.29, 2.85. And in quadrant 4, 6.28 minus 0.29, 5.99. This is a quadratic that is solved with the quadratic formula. My last example today is just a reminder that there are some problems that end up out of range. This is a question that all of us would think was pretty easy to factor. Sine square x plus 6 sine x plus 8. We would all quickly factor that. Sine x 2, 4, plus, and we'd be in business. So sine of x is equal to negative 2, and sine of x is equal to negative 4. However, if you remember from our studies earlier, for sine and cosine, the range is from negative 1 to positive 1 only. So that means this is too small, this is too small. There are no solutions here. Sometimes they're not, both of the answers won't fall out, but in this case they did. So just be aware as you look at these quadratics and you do factor, there are times when for sine and cosine only, your values may fall out of range. This will not happen for tan, cotan, secant, or cosecant. Not usually for secant and cosecant. So anyway, that's a kind of a recap about quadratics. Let's go back through them very quickly. Our first example involved taking a greatest common factor where we took out a factor of sine Always look for chances to remove the greatest common factor. Our second example involved, let's see, where is it? Okay. Right here. A quadratic example that would factor. This was tangent squared plus tangent minus 2. No problem breaking it down. 2 sets of answers, one from the chart, one from the calculator. Our third example involved a quadratic formula, and of course those are easy to spot when they will not factor. This was the quadratic formula example. Hope you made notes about that. And then finally we ended with a reminder that not always will the answers be in range. This is quadratic trig equations. Hope the video helped.